Hello everyone and welcome to yet another recreational programming session with Mr. Azuzin. So we're going to continue working on Panim, which is a programming animation engine that allows you to develop this kind of animations. Look at that, isn't that poggers? That's pretty freaking poggers, I think, right? So I'm going to be using that for making a video and stuff like that. So, so I was working on this animation. It's actually a pretty cool animation. I'm super proud of it. But there is a little bit of a problem with this specific, with how this specific animation work. So essentially, what I'm trying to do, I'm trying to simulate how a Turing machine sort of like executes its instructions and stuff like that, like how it executes them. Right, as you can see, like every time it performs one of these actions, right, so because here we have, like what you have to do if you are in a state inc and reading this symbol, right, so let's actually start over, right, so there we go. So as you can see, you are in a state inc and here is a state inc and you're reading 1 and here is 1. What you have to do, you have to write 0, move to the right and switch to the state inc. And since you are still in the state inc, it's not going to switch anything. So essentially what I want to do, every time it performs one of these side effects, I want them to sort of pop up. Right, so to indicate that I'm performing them and I want to perform them simultaneously as I perform them actually. So let's actually slow down the entire animation a little bit. So as you can see, it starts to sort of enlarge, and also it starts to do this kind of thing simultaneously with like as I switch the whole thing. Right, look at that. So look at both of these things. Right, and then as you can see, it starts to move to the right, and as it moves to the right, I enlarge this thing. Right. So, and then it switches this thing again, and then moves to the right, and so on and so forth, right? So until it reaches the situation when it's inc 0, in that case, as you can see, we switch to this sort of state, or we switch to 1, we then move to the left, and we are switching to the hold state, right? So we're switching to the hold state, as you can see, here is the hold state, and this is where the problem is. It kind of looks derpy, doesn't it? Right, so when these things playing and changing and these things so popping up, they feel a little bit out of sync. They kind of feel a little bit out of sync. So let's actually play it one more time and you will see what I mean here. Look at that. Especially when we switch to the hold. Right, it kind of feels a little bit weird. So they're sort of like out of sync. So essentially, what I want to do, I want maybe to, when I switch this state, to also enlarge this thing to the size of this thing. So then when they settle back to the original size, they do that simultaneously. They do that simultaneously. So, and what's interesting is that to do this kind of animations, I'm using different interpolation functions, right? I'm using different interpolation functions and stuff like that. So let's actually go to my paint and I'm going to demonstrate what I mean, right? Okay, my paint is starting. So maybe I should actually stop Panim because it's a little bit heavy on resources sometimes, especially when I have a lot of things. So let's actually look at the coordinate axis, right? So we have some sort of a coordinate axis like this, and I have the xt, so we're going to denote that as a time, and then we have a function f of t. So I usually consider the function from 0 to 1, right, from 0 to 1. Right, so if you take a look at maybe a function that looks like this, f of t equal to t, right, so this is basically an idea and it looks like this sort of line, right. So essentially, if I use this function to animate like transitions of, for example, moving of one object to another one, it will look kind of robotic, right? It will look kind of robotic. So instead, what I do instead, I actually use a slightly different function. I use smooth step that I think it roughly looks like this, right? So not exactly, but roughly. Actually, let's actually use smoothing in my paint. Yeah, there we go. Almost. Right, it's something like this. Right, so as you can see, it starts up slow, then in the middle it ramps up, and then it slows down again. right? It slows down again, and it creates this sort of like a cool effect when there are transitions and stuff like that. So we also had sine step. So smooth step is actually, if I'm not mistaken, so let's actually do, so this is a smooth step. It's too long to type. Smooth step, right? So it takes t, and its formula, it's hard-coded somewhere in a source code. Let me actually see if I switch to a correct layout. Right, so we have a smooth step. It's 3 multiplied by t squared, right? 3 multiplied by t squared minus 2t cube. That's what it is. I also have a sine step, right, which basically takes a part of the sine wave that looks like this, like a half of the sine wave as well, right, and stuff like that. So this is basically different functions that I use to make the animation smoother and stuff like that. But to synchronize this sort of like motions, to make more complex things, I need a function that roughly looks like this, right? So essentially I need to sort of go yeah, maybe I'm gonna go like this. Then I have to overshoot a little bit in here, right? So overshoot a little bit in here, and then maybe go back, right? So because the symbols in a table, they're slightly smaller than the symbols on a tape, so to synchronize them in sort of the size and then settle down into sort of like the same size, I need to like overshoot over one a little bit. And how do I even define this kind of function? And on top of that, okay, so that's a really funny function, but I also want to be able to define arbitrary functions in here, like, you know, like in a vector editor. Right, like in a vector editor. And this is where I think the time has come to introduce Bézier curves. Are you guys familiar with Bézier curves? Bézier curves. Let's take a look at them. I think my okay, so my mouse is almost dead. So here are the things. So essentially, Bézier curves, you probably saw Bézier curves in vector editors, right, as already mentioned. So already have that in the description. So let's take a look at Inkscape, right? So let's open up the Inkscape. So some people do know them pretty well. That's actually cool. That's actually cool. So let's actually create a new document. Let's actually create a new document. Yes, yeah. Why is it bright again? Every time I open this thing, it's always bright, even though I explicitly say, bruh, don't make it so bright. Right, so this is gonna be the desk. Yeah, that's what I'm freaking talking about. And this one, yeah, let's actually make it maybe something like this. I wonder if I can save this entire thing. Probably not, right? So anyways, so essentially you can create this kind of thing, right? So which is the basically simple stroke. Let's make the stroke a little bit thicker so we can at least see it, and let's make it white, right? So again, so we can at least see it. So, and what these kind of things allow you to do, it allows you to have this sort of like handles, right, that you can control and have smooth curves like this, right? So it would be kind of cool if this was like basically how I have this axis, right? So this is basically t and this is basically f of t, and I could like control how exactly those things look like, right? So for instance, I could do exactly the shape of the function that I want. That would have been cool. Right, infinite smoothness, yeah, actually. I think they are infinitely smooth, essentially, right? So because it's a mathematical curve, right? So it basically depends on the resolution that you're rendering it with, right? So if you're going to be rendering it, right, you have to kind of pick this step, pick the resolution, right, and then you can just smooth it. So, and with the infinite resolution, it's going to be like infinitely smooth. So how can you even render this kind of Bézier curve, right? So there are some animations on the internet that actually tell you how to do that. There is a lot of, as you can see, formulas, scary mathematical formulas, but this is because it's Wikipedia. Right, this is because it's Wikipedia. Honestly, throughout my career, and like I noticed that a lot of mathematical and programming ideas are actually very fucking simple. They're actually, like, I haven't like seen like a mathematical idea that you couldn't just easily understand if you spent some time. And a lot of this bullshit is literally gatekeeping bullshit, like majority of them. And the more I do this kind of stuff, the more I'm getting convinced that, yeah, that's basically literally people trying to gatekeep shit. Like, and it's kind of like difficult to now convince me otherwise, because I've seen it so many freaking times. People just use that as a means to, yeah, so this is basically a good example on how they're rendered, essentially, right? So this is a very good example, but as far as I know, this is a quadratic Bezier curve, right? So essentially, you have two lines, right? And you interpolating between these two lines, right? And then you interpolate between the third line. This is a cubic one, and this is probably the one that we will need. Right. So the main sort of like operation that we will need to render the Bezier curve is going to be lerp, or a linear interpolation. Right. So let me actually pick maybe some sort of a bluish color. And this is a very important operation, honestly. I think this is like an extremely important operation. It accepts three parameters, A, B, and C. And T usually like between 0 and 1, right? So that's what it is. It can actually go over 0 and 1. So, but like usually you want it to be like between 0 and 1. And so what it does, it basically interpolates between A and B, right? So essentially you can think about it this way. The closer T to 0, the closer the result of lerp is going to be to A. The closer T to 1, the closer the result of the lerp is going to be to B, right? So A corresponds to 0, B corresponds to 1, right? So, and of course, you can go under 0 and over 1, and in that case, the result is going to be under A and over B. But usually this is not really what you want. Right, usually this is not what you want. So since it's basically interpolating between these two values, the implementation is going to be basically, you need to take the distance between A and B. So you're going to take BA, so this is the distance, and you multiply it by T. So that means that sort of length is going to be interpolating from 0 to the full distance as T goes from 0 to 1. And then you just offset by A. So this is the entirety of the operation, right? This is the entirety of the operation. So in here, I'm using A, B as scalars, but they can be vectors. They could be points in the space, right? So this could be A and B, right? So, and essentially, if T is going to be 0, that means we're talking about this point. If it's 1, we're talking about this point. If it's half, you will find this point, right? So this is basically lerp A, B, 0.5. You get the point, right? So the closer you are to 0, the closer you're going to be to A. The closer you are to 1, the closer you're going to be to B. That's the entirety of lerp. That's the entirety of lerp. So now, if you take 3 points, right? A, B, and C, and you connect them like this, right? You connect them like this. So you have two lines in here. So now you have T, and let's imagine that you start modifying, iterating over that T from 0 to 1 with some certain step, right, essentially. Right, so maybe 0, 0.1, 0.2, and so on and so forth. It doesn't really matter. You're iterating from 0 to 1. So then let's imagine that T is somewhere in the middle. You take a lerp between A and B, right, and you find a point. This is another point. Then you take the point between B and C for that current T, and this is the second point, right? Then you connect these 2 points and you get the third line. Then you do a lerp between this point and this point with the same T, and you get the point on Bezier curve for that specific T, right? And this is what's happening in that animations on the internet that you can see in here. So the more lines you have, well, this is the quadratic one, right? if you do this nested lerping, you see we have and stuff like that. If you do this nested lerping, you're gonna end up with a smooth curve. You're gonna end up with a smooth curve. So the more points you have, you can do that with, like, for example, 4 points like this in here, right? The more sort of control over the curve you have, the more control over the curve you have. So usually the Bezier curves that we use in the vector software, they're cubic ones. So essentially you have 4 points. Here's the first point, here is the second point, the third point, and the fourth point. So usually we don't draw the line between this point and this point, right? But it's kind of there. There's kind of like this another line in here, but we don't draw it. We just draw it, these things as these sort of handles that you can move around, right? So, and under the hood, Inkscape is doing that algorithm. Maybe not that algorithm, maybe something more smarter, but in the essence, it's doing that, right? In the essence, it's doing that. So essentially, what I want to do, I want to implement a system that allows me to use Bezier curves for the animations, right? So essentially, we have a task system which defines small predefined amount of work, right? For example, we have things like move scalar, right? So move scalar. So for the move scalar, you provide the pointer for the scalar, for the number, for the value that you want to move from one position to another. Right, you provide the target where you want to move that current value. You provide duration, like for how long you're going to be moving from its current position to the target, right? And then you provide interpolation function. Right, so in essentially interpolation function, what is it? It's a enumeration which tells what kind of interpolation function you can use. A scene step, smooth step. I also have scene pulse, which goes back to 0, right? It goes from 0 to 1 and then back. So you can do sort of pulses like that, right? Which convenient sometimes for these kinds of things. So essentially, I want to modify this entire thing to accept a custom Bezier curve. A custom Bezier curve. Right, but Bezier curve actually has a lot of freedom, but we need specifically a Bezier curve which defines a function from 0 to 1, right? It must define a function from 0 to 1. So because of that, there will be a little bit of a limitation on how we represent that Bezier curve that is going to be used in the animations, right? So for instance, we're going to be moving from 0 to 1. So that means the first and the last point that define the Bezier curve is going to be snapped to the left side, and the right one is going to be snapped to the right side to 1. Right, we should be probably able to modify their Y position, right? So move up and down, but generally I don't want these control points to move left and right. Right, because that doesn't make any sense. I want like a function that is defined from 0 to 1, preferably. So because of that, we kind of like don't want to move these things around. So, and then you also have to specify 2 other control points in here, right? So which are going to be obviously connected like that, and then they're going to be interpolated like that, right? Like so, and then created the actual curve and stuff like that, right? So there's probably also going to be some limitations on where we put those things. Maybe how to say that, the x of that point should always be less or equal to the x of that one, or something like that. So yeah, we'll need to think about that, but maybe generally we want to provide just like 4 points to define this kind of thing, right? And just use that for animation. But here is an interesting thing. This entire Scheiße, right? This entire Scheiße is not convenient to edit, right? So this entire Scheiße is not convenient to edit because, like, am I going to be modifying the points like directly, right? Like in the code, like numbers and stuff like that. It would be kind of nice to have some sort of editors that looks like Inkscape, where I could just drag around, just like jerk off these little red things, to my liking. You know what I'm talking about? I want to like jerk off these things, like, and then adjust and stuff like that. So I need some sort of a freaking editor for this stuff. And yeah, that's gonna be the point of today's stream. Let's freaking implement an editor for the freaking Bezier curves so we can use them in animation. The fuck? Isn't that fucking cool, mate? Isn't that fucking cool? Right. So yeah, that's basically the topic for today's stream. We're going to be implementing this kind of thing, and the editor will generate basically the parameters of the Bezier curve that you will be able to then use in the functions. You'll be able to copy paste those things into your code and stuff like that. Right. So the idea is going to be maybe the Bezier curve editor is going to be one of the panim animations, because the panim animations can interact, right? So it's usually like kind of discouraged, but they can use, right? So they can use the input methods of Raylib. We can utilize that. We can implement the Bezier curve editor as the panim animation, and then we can ask that animation copy the Bezier curve parameters to the clipboard. So then you can Control V into your animation. Isn't that cool? Right, so you're like adjusting this kind of stuff, right? And maybe Bezier curve parameters are going to be like array of floats, right? So, you know, the actual Bezier thing is going to be basically like a float, you know, PS or whatever, right? And then you're going to do basically there's going to be a special button which you click, and it copy paste into your clipboard things like this 13, 14, blah 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 blah, all of the parameters, and also it formats it as a C code, right? So it not just gives you parameters in a clipboard, it formats it as a C code that you can then Control V right into your animation code. So it just like generates C codes and puts it into the clipboard so you can copy paste it into your stuff. How about that? Isn't that epic UX? This is literally God UX. The God UX tool that generates C code, puts that C code into your clipboard so you can copy paste it into your project. This is literally God UX. This will revolutionize software development. I'm fucking anyways, maybe we could, I don't freaking know, it would be kind of cool to have some sort of like a text editor extension that detects these kind of things. Oh, this is a definition of Bezier curve. You click on that definition, it creates a separate program where it opens up the Bezier curve editor with these parameters. You can edit them, then you close it and it saves it back into this kind of parameters. Well, but we're probably not going to go into that, but that's kind of cool idea, right? So in the code, like directly, you just click on the array. Oh, it's a Bezier curve. Let's edit that as a Bezier curve, like TempleOS, right? You know, so you can have a code, and in the code itself, you can also have sprites like built into the source code of the program, and you can like draw them directly and shit like that. Isn't that fucking boggers, meine Freunde? Holy shit! Cheers for that. So yeah, I'm too excited for this kind of shit. I'm sorry. So yeah, that's basically what I wanted to do today, right? So I wanted to implement like a simple Bezier curve editor, and I think I already did this kind of shit before in one of my previous projects, but I don't know where it is, so it's probably somewhere on GitHub. So yeah, anyway, let's close all of this shit and maybe start, maybe a fort. Haha, let's do fort. So let's go. I'm gonna try to rebuild. Okay, everything is already rebuilt. So I have a template animation, template.c. And I'm pretty sure it's already built. If I do build lib template and run this entire thing, I'm not supposed to actually put in % here. There we go. So here is the template. So what we probably want to do, we probably want to copy paste this entire thing, and let's actually call it Bezier. Bezier.c. All right. So I'm going to open nob.c, and I'm going to include Bezier into the build, like so. So let's actually do something like It doesn't. Oh, okay. Bezier. Lip Bezier. All right. So let's go. So this is gonna be no. And build panim, build lip Bezier. There we go. So panim template. So I'm gonna open the Bezier, Bezier, and let's change it to maybe Bezier. Can I actually put like a ampersand in here or something? Not ampersand, but you know, diacritics and stuff like that. Are they called diacritic in French language? I don't really know, right? So, but this kind of things. Accents, sort of like accents. Is it going to? Thank you, Raysan. Very cool. I'm pretty sure there's a way to enable that. All right. So yeah, you have to do draw code points. Yeah. You probably have to do draw code points. Right, so I don't really care about it right now. So, okay, let's maybe get rid of all of that. And we probably want to actually start with creating a camera, right? So let's actually start with creating a camera, because with the camera, it's a little bit easier to center things around. Because of that, you know what? Let's bring this stuff back, right? So I'm going to create a camera 2D. Camera, we're gonna zero initialize this entire stuff, and we're probably gonna do begin mode 2D, right? Begin mode 2D camera, like so. Let's maybe even wrap everything into the scope so we can indent this entire shit. Like so. If I try to rebuild this entire thing and reload it, we can't see shit in this mist. And you know why? Because the zoom in the camera actually has the zoom. It must be 1, otherwise it's going to be 0, so it's going to be like actually infinitely small, right? And you won't be able to see shit. There we go, and now we can see all of that, right? So it points at the center, right? So that means this is 0, 0, and it points precisely at the center, but not really actually, because we're aligning this entire thing a little bit, right? So we do like a position alignment and stuff like that. Honestly, we should probably not do any position alignment, right? So otherwise we won't be able to see if the camera is working correctly. Maybe I should include the camera into the template, right? Because it automatically makes everything easier. Yeah, there we go. So we need to now center or offset this entire thing by the half of the screen size, so to speak. So, and I think in TM we already kind of have this kind of stuff. Yeah, there we go. So we have offset, and offset is basically half of the screen width and half of the screen height. Okay, so let's actually put this kind of stuff and rebuild this entire thing so it doesn't like the comma and stuff like that. So let's actually do it like that, and it's kind of aligned, but the whole thing in here is not aligned, but it doesn't really matter. We don't care about that. Okay, good. So yesu. So now we have to actually render something, right? So we have to render the axis. So to render the axis, we probably have to use the draw line thingy, right? So some sort of a draw line thingy. So where do we have a draw line? Let's go into Raylib and let's find the function draw line. Yeah, so I want to be able to specify the thickness, right? I think being able to specify the thickness is actually very beneficial for us. Right, so the thickness, let's say like axis thickness, right? So axis thickness. And for now, it's going to be defined as this. I'm going to move it to preprocess soon, right? So, but for now, it's going to be something like this. So it's going to be 5, maybe 5 pixels, right? So then we're going to have a color, which is axis color. And what's going to be that color? I want to kind of use blue for now, right? So this is going to be blue. Axis color, there we go. So we have to specify the position. So let's say that the start position is going to be 0, 0, right? So this is going to be 0, 0. We're starting at 0. And end position is going to be probably, so it's going to go up, right? Let's define first y-axis. So that means this is going to be 0, and this is going to be sort of like the length. We need to specify something like axis length, and let's define it like this. Axis length is going to be, let's say, maybe 100, right? So we can always adjust this entire stuff. We can always adjust this entire stuff. So this is going to be essentially start position, and this is going to be the start end, right? End position, right? So this is the end position. So let's go ahead, recompile this entire stuff, and see if it works. Look at that. So it goes down apparently. I see. So let's make it negative, I suppose, right? So there we go, it goes up, but it's too small. Let's actually make it like maybe 500 or something like that. It's too, no, it's not too much actually. Look at that. Yeah, it's fine. That's totally fine. Right, so, and now we can actually draw the second one. We can probably inline all of this stuff with a little bit of a clitoral, if you know what I'm talking about. You can always just, you know, inline that with a clitoral. So let's put it like that. So it's a single statement. Working with a single statement, I think, is a little bit easier than just 3 statements. Right, so we have to put parentheses in here to indicate that this is in fact a clitoral. Okay, so that is in fact a clitoral. So now I can create a second statement, and in here I can just move the axis length to the right, and there you go. Right, so we have the second axis like this, right? That's what we have. Right. So it would be kind of nice to actually align. This looks like shit, by the way. Like, what the fuck is this? Absolutely fucking disgusting. So I think we have to maybe, in terms of like x and y, we have to subtract like half of the height or something. We'll see. Let's just keep it as it is. Let's just keep it as it is. So I want to align the view at the center of this thing. I want to align the view at the center of this thing. Because of that, I think we have to specify the offset plus the axis length and half of the axis length. Right, and plus this. So that means these parameters should be visible for the camera definition, right? So we're actually promoting them in here. Right, so now if I go here, it's actually went a little bit, you know, sideways. So let's actually try to subtract this entire thing. Okay, so this thing seems to be centered properly, but what about the y-axis, right? So is it fine? Nah, the previously it was actually better. Previously it was actually better. So now we have something like this, and it's kind of roughly aligned, and it stays aligned as we resize this entire thing. So that's totally fine. I'm kind of fine with this entire thing. Let's actually get rid of the Bezier curve text, right? So I don't think it's useful anymore, right? So it's only distracting. I was using it as just sort of like a, it's sec-faulted, motherfucker, sec-faulted. That's why you should program in ROS. Okay, so right, so this is basically the axis that we have in here, right? That's pretty cool. That's pretty cool. That's pretty cool. So now, what we need to do, we need to define the handlers, right? So the handlers that we're gonna put in there. Right, so let me see what we can do in here. So I suppose we're gonna just draw a circle. Right, draw a circle. Draw a circle. So we probably want to use draw circle V, so we can specify center as a vector, and then the radius and the color and stuff like that. Okay, so that's cool. So that's the one I want to use. So the center is gonna be, let's put it at 0, 0, right? So because we're just experimenting and stuff like that. So let's call these things nodes, right? So this is going to be a node, and we're going to say this is a node radius, radius, okay. And then we're going to also have a node color, So let's just like render them and see if we can see them. So node radius is going to be, let's say 50, right? We can also adjust all of that stuff. So the color, node color is going to be something like red. Right, there we go. What the fuck is going on? Emacs. Emacs is just like having a stroke or something, I don't fucking know. All right, that's too big, honestly. That's a little bit too big. So let's make the radius a little bit smaller then. So how about 25? Half as small. Looks all right, I suppose. Maybe 15. What about 15? I think 15 is all right. Yeah, that's fine. That is totally fine. That's pretty cool. I really like that. So That's fine. Right, so we're probably gonna have more of them, right? So another one we could probably put something like, so in terms of axis, gonna be axis length, the full axis length, and then minus axis length for y. So the second one is gonna be on that side, right? So this is the second one. And we should be able to kind of control them, if you know what I'm talking about. We should be able to control them. So to be able to control them, we need to know whether we hovering over them so we can just grab them and just drag them around and shit like that. So we should be able to do this kind of stuff. Right, so we could check whether the mouse position, right? So we need to get the mouse position, get mouse position. All right. So we can take the mouse position. So this is going to be vector 2 position. Let's call it mouse, right? So, and as far as I know, we have a bunch of functions that check the collision, right? So collide, collision, or something, check collision, yeah. Point, circle, check collision, point, circle. So this one is very useful. This one is very freaking useful. Okay, so essentially we can just take this entire stuff and maybe we can like put it into a separate sort of thing in here so we can factor out this center. And the reason why I put it into a separate scope is because I want to have a similar variable called the center for a different thing in here too, right? So, and once you have this center, you can quite easily check whether the mouse at that specific center, at that specific radius, intersects, right? Whether it intersects or not. And if it intersects, we probably want to actually draw this entire thing with a different color, right? Node, you know, hover color. Let's call it hover color. And if it's not hovered, we're gonna just draw it as color, right? So the hover color, let's maybe make it yellow or something like that. The color of the piece, right? So this is going to be the color of the piece, yellow one, right? And yeah, so we're gonna just leave it as it is. So this is the first point essentially, and this is not going to work that easily, as you can see, because we are having the screen coordinates. Right, so these are the screen coordinates, mouse is in screen coordinates, but the entire thing is in the world coordinates. So what we need to do, we need to take the mouse position and somehow map it into the world coordinates. Right, as far as I know, Rayleigh does in fact have something like that. I don't quite remember. So let's actually find all the functions that accept the camera or something like that. Right, so I think it's near begin mode to D, then the camera to D. I don't know, get camera matrix. We can take a matrix. Oh, okay. So get screen to world to D. So get the world space position for 2D camera screen space position. So this is probably what we want actually. Believe it or not, this is probably what we want. So we can go ahead and just do the conversion. So we take the position of the mouse, right, and we take the camera and we convert this entire stuff to the world coordinate. So that's probably what we want in here. That's probably what we want. All right, so now if I do... Holy fuck, we can detect whether we're hovering over, so that means we can drag it. All right, I'm sorry. I'm a professional streamer, all right? So I'm supposed to do this kind of shit, otherwise the stream is not engaging, okay? Right. Can your React do that? Can your fucking React do that? I don't fucking think so. You can't do this kind of shit in React without use effect. You literally can't do that. It's fucking impossible. Here, fucking easy. Fucking easy. Anyways. So, let's continue. Yeah, so essentially we kind of need to store these things somewhere, right? So, okay, like I can check that it, like hovers over this entire stuff and everything, but I need to probably store this entire thing as some sort of a state, right? I need to store it as some sort of a state. So we probably want to take all of these centers and factor them out into sort of like an array of nodes, if you know what I'm talking about. The array of nodes. So it's going to be vector2 nodes, and we're going to have 4 of them. Like for now, we're going to have 2 of them. All right. We don't even have to specify because this thing is going to automatically do that for us. I also want to make it static. I'm not sure if it's a good idea, right? So because the plugins are not really reacting well for like with static, right? Reacting. So what we need to do, we need to take all of these values and kind of move them in here, right? So we're kind of moving them in here, including this one. Right. So yes. I also want to be able to actually have the amount of these nodes. So we're going to do something like maybe nodes count, which is going to be equal to knob. Do we even include the knob? I think we do include knob. Excuse me. All right. So we don't include knob. Okay, so the compiler will tell me that's something that doesn't really matter. So in here, what we want to do actually, we want to iterate through all of the nodes, right? So I'm going to be iterating from 0 to nodes, nodes count, right? So nodes count. Did I call it nodes count? I don't remember. Yeah, I call it nodes count. So and the center is in fact one of the nodes, right? So nodes I. Yep. That's the center, and then here it's going to be nodes I. So now I can completely get rid of all of that, and now this entire shit is supposed to work for both of those things. So it doesn't like axis length because it's a variable, and you can't, because it's a fucking motherfucker. And that's why people use preprocessors in C. Even though it would be convenient to actually, you know, use constants and stuff. We could try to make them constants. Okay. Can I make them constants? But it's not going to help anybody. Yeah, so implicit... implicit... Okay, so that worked actually. Wait a second. That fucking worked all of a sudden. If I make them constants, it actually... What the fuck is this shit? Is this C++ or something? But anyway, so we need to include knob.h for the append, or for like... Why did it fucking work? So you can define a local non-static constant variable, local non-static constant variable, and then use that variable in the definition of a static array. Because it's known and compile. Cool, but why then I can't do shit like that? Where I have something like 2, and then I do xn. It's known at compile time. Why the fuck I can't do that then? GCC, this is a good point. GCC extensions. Yeah. It's fucking pedantic time. Motherfucking pedantic time, alright. So where are all of these things? So let's actually do pedantic. Alright. And let's actually do knob, but we actually do force. Right, so it's going to rebuild everything in here. All right, so it will take some time to rebuild all of this thing. Got him! Fucking got him! Oh, okay, so it actually... Oh, all right. C++ designated initializer only available... Well, I mean, it's because of C++. Fuck C++. Right, so there's a little bit of C++ building in here. Fuck this shit. I don't care. Right, so let's actually only build C. Right. So it's just complaining about like me using C stuff in C++. So what is it? It doesn't like something about X macros. It really doesn't like. SOC for bits. Okay, so that's fine. This is fine. Right, because we're assigning, like we're casting function pointers on the platform where it's fine, right? So this kind of stuff is fine. We might as well, so it's pedantic, right? So you can't really even disable that. No, even pedantic doesn't complain about this kind of stuff. Right, where is the Bezier? Right. Even pedantic is totally fine with you having local const variable and using it in the definition of a static array. How are you supposed to do that with ISOC then? You don't, as far as I know. You mean the casting of function pointer to void star? You're not supposed to. It's not standard C. This is not standard C. So because it's a very platform specific feature. It's a very platform specific feature because depending on the platform, there are platforms where size of the data pointer and function pointer are different because functions, the codes, are stored in a completely different place or sometimes even addressed differently. Right. A good example off the top of my head is WebAssembly. In WebAssembly, you have a data, you have a memory, but the code is not stored in the memory of WebAssembly. Code is located in some weird place that is not actually addressable for security reasons, I suppose. Right. So the code and data, they are in two completely different places. And in WebAssembly, you can't just take a pointer to some code and modify it like you do in x86-64. And because of that, how you do function pointers in x86-64, it's not possible in WebAssembly. The way they do function pointers in WebAssembly, they have so-called tables, right? So if you have a function and to which you want to take a function pointer, the C compiler Clang will automatically create that function in a function table. So then you can call that function by its index. On WebAssembly, in WebAssembly, function pointer is an index in a table, right? So because of these kind of things, right? So where you have platforms where function may not be in the memory, the ISOC, the standard C, simply prohibits you to convert between data pointers and function pointers. But we know 100% that we are on x86-64. Because of that, it's fine, right? I don't really plan to run this thing on WebAssembly, for instance. So yeah, that's basically how it works. What if you explicitly cast? I think it's going to be like on WebAssembly, right? So if I take the data pointer and explicitly cast it to a function pointer and like just force the compiler to do that, I suppose it will take the value of the address and will interpret it as the index in the table. But usually table contains like few dozens of the functions, so it's basically will try to access that table out of bounds and it will probably crash. So that's how I predict what was going to happen if you try to do this kind of stuff. So it's probably not going to be good, right? It's not going to be good. So that's my hypothesis. That's my hypothesis. Anyways, so yeah, so apparently you can do that, but you can't do the stuff where you define const int n and then define an array out of that. So you can't do that. Bizarre, absolutely bizarre. C is bizarre. More in terms of if GCC will let you. Yeah, maybe it won't even let you. But I mean, we could try to check that, but I mean, that's too much of a tangent, unfortunately. Too much of a tangent. Anyways, so let me try to recompile this entire thing. I'm gonna actually get rid of the pedantic, right? So because it's kind of staying in my way. Right, let's rebuild the entire thing. Bezier, 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 Bezier. Okay. George Bezier. Okay. So let me take a look at this entire shit. So now this entire stuff works literally anywhere, actually. Look at that. Right, so it works for both of them. And the question is, how can we start dragging those things? Not drag, dragging, not drag. I'm dragging my point. All right, so I suppose maybe we're gonna keep the index of the, like, I mean, English is not my first language, okay? Like, you guys have way too many vowels, like e, u, and all of they different, and all of a sudden they're changing the meaning of the word, right? So why do you have to distinguish between drag and drug? It sounds the same for me, right? So What's that? I can't even hear the difference. Yeah. So it's kind of similar with the Russian sound, right? E, and U. Do you know, like, do you hear the difference between these two sounds? E, U, E, U, E, U, E, U, E, U, E, U. Sorry. A lot of people actually say that they can't really hear, like English speakers specifically can't really hear. As a okay, well, Poles, that's a little bit cheating, right? So being Polish is cheating, okay? Being Polish is cheating. Oh, so in German it's also kind of similar. I see. Yeah, okay. In Hungarian as well. Spanish. Okay, so people can hear that. I suppose it's only English speakers can hear it. English has E and U. It's the difference between shit and shit. Not really. I don't know. Maybe. In Russian, when do you say a or o? It's the classical reduction of o's things, right? So essentially, the o's that are not under the stress, that they reduce to a, and quite often into schwa, right? So schwa is basically some sort of incomprehensible vowel sound, right? That's the definition of schwa. Right, so incomprehensible vowel. It's some sort of vowels there. It's difficult to understand what the fuck it is there, but it's schwa, right? Right. So it's basically you have o. It's not under stress, so it's reduced to a or just schwa, especially if you speak quickly. Okay. So, Yesu. That's why Russians say production instead of production. Yeah, exactly. That actually explains it. It's kind of like it's on the level of reflex, right? So we so got used to that like it's just like we transfer that to other languages that we speak. All right. So what we do in here, I need to keep track of the currently dragging node, right? So dragged node. So I suppose I'm going to be using integers, so I have an opportunity to actually say that I'm not dragging anything by putting -1 in there, right? So essentially now if I'm if dragged node is greater or equal than 0, what we want to do in here is actually take that node, and it's kind of important that this specific node as well is less than the nodes count, right? So less than nodes count. We can even maybe swap this kind of stuff around so it looks like a range in here, right? But the problem is here is that this is integer and this is size t, and that effectively means that we have unsigned comparison with a signed thing. But I don't think it's that big of a deal. Yeah, comparison of integer expression of a different signers. Right, so after checking that this thing is greater than 0, we know that it's not negative, right? So that means it's safe to convert it to unsigned one, and it's not gonna like underflow or overflow or anything like that. So it's super safe to actually do something like this, right? Because we know it's positive after checking this specific thing. So, right. So we need to do that because this is C, it's not Rust. It's not gonna at runtime check like out of bounds indexing and stuff like that. Right, so we're gonna do nodes, dragged node, and we're gonna just assign the mouse position to that specific node if we're currently dragging that thing. All right, so essentially now, so if we hover in a certain thing, we're gonna draw it one way or another. Right, so that's totally fine. So another thing we probably want to do, if we're currently not dragging, right, but we are hovering over certain thing and pressing, so that means we have to do that in a loop, right? So like the coloring kind of makes it a little bit difficult. I think the coloring kind of makes it a little bit difficult, so I think I'm going to actually extract this kind of stuff to here, right? And maybe even do something like that. If hover, do that. Otherwise, do that, like so, and then get rid of the entire condition in here, right? So that's, I think, a little bit better. Right, if we're currently dragging something, right? So if this entire thing is dragged, we probably don't do anything. Otherwise, if it's not dragged and we hover and is mouse, there was something like mouse pressed, I think. So we need to find mouse button. Yeah, so there is a mouse. It's kind of interesting, right? I suppose people often confused mouse left button and mouse button left. So both of them are fine, right? So both of them are fine. So let me now see if we hover and mouse button is pressed, we can quite easily say that the dragged node is essentially, it's going to be the index, right? So the drag node is going to be essentially the index. And in fact, like, we don't really do anything if we are currently dragging as of right now, so we might as well just do something like this. I could have applied De Morgan law, but I don't want to do that, right? So honestly, so we might as well even do something like dragging and just put it like that. And just if dragging, we're updating the drag node like this. So then later we can just do dragging, dragging. There we go. So it's kind of important to check that the drag node also doesn't go over the nodes count, so you don't have out of bounds access or stuff like that. So yeah, we can do these kind of things. So we can do these kind of things. Does it compile? All right, let's go. So what do we have in here? Can we? Oh, okay. I think I'm an idiot. All right. So I suppose what we have to do is mouse button pressed. All right. Is mouse button down. Right. So if you're not dragging and you hover and is mouse button down, we actually do that. If you are dragging, right, so we kind of still have to do this kind of stuff, and is mouse, yeah, I think we need to do that, mouse button pressed, and if we're dragging and mouse button released, specifically mouse button left, we have to set dragged node to -1. There we go. So that's probably what we have to do. Is it going to work? Let's find out. Let's find out. Okay. Doesn't fucking work. Doesn't fucking work. Cool. All right. So if not dragging, we hovering and mouse button pressed. So I should become drag node. So on the next iteration, we should be setting. Did I make a fucky wacky or oopsie doopsie somewhere? I don't fucking know. Where did I make a fucky wacky? Set dragging, maybe it's already set. So dragged node, we just set in dragged node. I don't fucking know, mate. I don't fucking know. So okay, so initially dragged node, right, it's -1. It is -1, so that means this thing is gonna be false. Right, so maybe it does make to debug, it makes sense to debug, so I can just step through this entire logic, but I can kind of step through manually, I think. Right, so this is going to be false, so this is going to fall through. Okay, so that's fine. So we're checking that we're hovering this entire stuff, right? So we're drawing everything accordingly. If we are not dragging, so we're not dragging, we're hovering and the mouse button was pressed, the left button specifically, I know what is going on. All right. Because it's reset on each iteration. That explains it. That actually explains it. Okay. Right. So still doesn't fucking work. Okay. I'm gonna try to restart this entire stuff. So I'm rebuilding everything. Okay. So, all right. Now it works. I just need to actually restart the whole thing. Okay. So that works. First try. Dub. All right, so and now, by the way, I can have many of them. Honestly, I can actually have many of them. To be fair, like this kind of static stuff would be way better if it was part of the plugging state itself. So then I could have many of them. All right, so we can maybe even introduce something like type-def struct nodes. Right, and in here, this is going to be just a vector items. Right, so then we're going to say size count, and then capacity, and so on and so forth. So then later I can say nodes. Right, there we go. So we have nodes in here. So when I load in assets and stuff like that, plugin reset. I suppose plugin reset is essentially taking the nodes, setting them to 0, and basically reappending them back, right? So we can do knob di append, right? So p nodes, and let's maybe actually put all of these things in there. So that means I need to be able to access all of these parameters now. So the time has finally come to make them pre-processed things in here, unfortunately. I wish I didn't have to do that, but it's just C, right? So there's no way around that, unfortunately, chat. Unfortunately, it is what it is, and it isn't what it isn't. Is it not? I think it is. The missile knows where it is because it knows where it isn't, right? So the usual stuff. So maybe I have to do it like that, actually. So we have items, capacity. The plugin reset, what kind of stuff do we even set in there? That's a good question. So we set these things, 0 and minus axis length. Right, so let's actually put them in here. Maybe I'm gonna use a little bit of an Emacs magic yet again. Knob da append, right, so this one is gonna be vector 2. We are pushing all of that stuff into nodes, like so. It would be also better to wrap it around like that. There we go. So that makes it a little bit more dynamic. So that kind of gets rid of this entire stuff. And we also need to keep drugged node in here as well. What the fuck was that? Why did it copy everything in here? I only copied drag node. I suppose it's kind of appended all of that stuff in there. So in the -1 also has to be in here, I suppose. Dragged node -1. Dragged node -1. Okay, so we move this stuff around, so that means the entire shit doesn't compile. Let's go through the compilation errors. What are you fucking asking me about? Just recompile. Okay, freaking change it. Jesus Christ, bro. All right, so, okay, nodes. Okay. All right, so dragged node, right, so now it is accessed through the P, right, so it's accessed through the P. What else do we have in here? Nodes count. Nodes count is this thing. Nodes count. Let's actually query replace all of the nodes count with basically p nodes dot, and that's about it. So that it was only one in here. So this one is items, another one, yeah, dragged node. So yeah, so once you have like a statically typed compiled language, it's super easy to refactor things without even any ADE and any LSP and shit like that. You just follow the compilation errors and then it just works. Isn't that beautiful? I think it's pretty freaking beautiful. It's a general approach. General approach are always good, in my opinion, my friend. All right, so that seems to be working. That seems to be working. All right, so that's segmentation faulted, but that's fine. It's kind of expected because we changed the schema of the whole thing. Right, okay. So I wonder now, so what we can do. We can go to the plug reset, and then we can say, okay, I want to add something like in between these things, right? So this one is going to be half of this stuff, and this thing is also going to be sort of half of that stuff, or maybe -0.5, right? Something like this, right? Then I'm going to hot reload and then restart. Now we have 3 points, and we can have as many points as we want. Actually, as many points as we want, honestly. Right, we can add another fourth one, which is like 75% or something like that. Right, so now we have 4 points in here. So as you can see, we're probably not going to have more than 4 points because that's everything we need for the Bezier curve. Right, so and we also kind of want to limit the position of the curve to be inside of the rectangle, right? So that's one of the things we probably want to do. So as we move this entire stuff, right? As we move this entire stuff, let me actually take this node, right? I want to do something like this because this is a very huge expression. I don't want to be writing it over and over again, right? So I've got this thing, then I'm setting the mouse to this expression, and now what I want to do, I want to kind of like clamp the x between 0 and 1. So does RayLeap have anything like clamp, at least in math? So do you have clamp? It does have clamp. It does have clamp. Look at that. Isn't it a fucking poker smiley for you? So does it have like a clamp that is, you know, accepts the pointer or some shit like that? Where's the math? So clamp. All right. Yeah. So there's a very convenient paradigm with clamp. Is basically you do clamp. I think I saw that in Jai, right? So I think I saw that in Jai, right? So you do something like that and basically like modifies it. Right, so but without that, you kind of have to do this kind of shit, which is fine. Okay, it's fine, but it's like with the pointer, it's a little bit more convenient, I think, right? It's just like you don't have to do the assignment. So it's more like imperative and shit like that. Anyway, so it's fine, it's fine, it's fine. It doesn't even fucking compile, mate, because it's what? It's actually vector 2, right? It's actually vector 2. Okay, fine. All right, so now can I? Oh fuck. It's actually not 1, it's 0 and axis length. Yeah, so we also will have to like map the ranges from 0 to axis length to 0 to 1, right? Axis length. All right, so let's actually do something like this, and let me see. Let's kind of wait. Why does it go outside? That doesn't make any fucking sense. Wait. Nope. Am I an idiot? Am I actually an idiot? So did I? Yeah, so probably negative. Yeah, you're right. You're probably negative. All right. Why does it clamp it? Okay, so it clamps it like that, but oh, that probably you have to swap them around as well because the negative is less than 0. Freaking the coordinate systems, I swear to God. Finally, and they are clamped within that rectangle. They're clamped within this rectangle. This is actually beautiful. This is absolutely beautiful. And yeah, so this thing, for this specific thing, I think it should be clamped like in here. It should not go left or right or anything like that. The same thing for this one. And for these two, I think they should not go over each other, right? So they should not go over each other. So yes, so that's basically the idea. All right, so, but I'm already streaming for 1 hour, right? I ran out of tea. I think I want to make a small break. I want to refill my cup of tea, and after the small break, we're gonna continue working on this Bézier curve editor. So, sounds good? Sounds Gucci? Sounds Tamaguchi? Let's go. All right, so let's go ahead and maybe limit the amount of nodes, right? Maybe it was a bad idea to actually introduce these kind of nodes things, right? So I don't really want to have like infinite amount of nodes. I want to have like exactly 4 of them. So let's go ahead and just like do something like this. So let's go back in here. So, but it would be kind of nice to maybe count nodes 4 in here, so I can easily just iterate through them when it's needed. But generally, I know precisely how many nodes I'm gonna have, and they're gonna be even clamped differently. That's the thing. They're gonna be even clamped differently. So now, let me Jesus fucking Christ, bro. So in here, what we do? I suppose we can just hard code all of these things, right? So can I just go ahead and say p nodes, and this is gonna be 0, 1, 2, 3, blah blah blah. And this is that, and then this is that. So 1, 2, 3. All right. So now let's go to the rest of these things. Okay, so there's extra parentheses that I didn't like. That is fine. That is totally fine. So we have p nodes count. I want to grab this thing and I'm going to replace that with the count nodes. There's only 2 of them, that's fine. What's the next one? When we're accessing this thing, I'm gonna query replace it with just nodes. And that seems to be working. So let's actually go and start panim. And yeah, it's still working. It is still working. So that's cool. So one of the things I want to do, actually, I want to connect the first and second node, right, together, and third and fourth. So then they will create these 2 handlers that you can move around and stuff like that, similar to Inkscape, right? Let me now see how we're going to be approaching all of that stuff. So we need to draw another line, essentially. Draw line, and we're going to be drawing P nodes 0. So this is the start, and the end is going to be 1. So the thickness, maybe, how can we call that? So we can call it handle, and this is going to be handle thickness and handle color. So I'm not really sure how exactly, what's going to be the color in here. So we can make it maybe green or something like that. I don't freaking know. We'll see. And then we're going to be connecting, so 0, 1, 2, 3. Right. So we're going to be connecting these things. All right. So the thickness is going to be maybe around the same as the axis thickness. Maybe half of that. How about half of that? So handle color, maybe, let's put it also as yellow. All of that can be adjusted, right? So don't really want to spend too much time on, yeah, there we go. So that's what they are. That's how they look like now. Right, these 2 things. So yeah, that's pretty cool. By the way, I just recently remembered, Ray Leap has support for Bezier curves. I can actually render them. Yo, draw segment cubic Bezier curve in and out in the play. But why does it accept? Wait, why does it accept only 2 points in here? Draw segment cubic Bezier curve in out interpolation. So I would expect to have like at least 4 points. So if it's a cubic Bezier curve. Okay, let's actually try to do that. Like how, it would be kind of actually super convenient, because then I wouldn't have to actually draw it myself. So let's actually put it between these 2 things. Right, so, okay, oh, it's, you can't control it at all. That's lame. That's fucking lame, bro. Yeah, so it's kind of useful for diagrams and shit. All right, so it's very useful for diagrams, but for what we're trying to do, it's not particularly useful, right? So it's like you can't adjust it and stuff like that. Okay, so that's fine. That's totally fine. So it's very limited in that regard, right? But yeah, whatever. Okay, so now what we want to do, we want to probably try to go ahead and just like render the Bezier curve that is defined by these 4 points, right? So we can do the whole nested lerping thing, but if you take all of this nested lerping and basically turn it into a formula that depends on just t, you can actually end up with a very nice formula that doesn't require like constant lerping and stuff like that. So you end up with a cubic equation or something. So I think it was even described in that Wikipedia article. We can just yoink that formula and just use it to sort of sample the Bezier curve and yeah, just render it. So linear, quadratic, where is the cubic? Yeah, here it is, essentially. So that's literally the formula, right? So P0, P1, P2, P3 are the points, and then T is basically the T parameter from 0 to 1. So, and you basically sample from 0 to 1 with a certain resolution, and you just plug into that formula, and it will just give you the Bezier curve, right? So let's just go ahead and do that. So I think it's going to be interesting. So let's maybe do the following thing. I'm going to introduce something like a res, which is going to be resolution. So let's, like in how many parts we can define one? Let's divide it into 10, 100 of them. or maybe like 30, right? So we don't really want to draw too many points, right? So because it's probably going to be very very long. Oh, there's the spline Bezier quadratic. Okay, so that's actually pretty cool. Spline Bezier. Ooh, this is actually good. Okay, so that's actually pretty cool. So that means we won't have to do that. All right, so let's go ahead and do that. So that's super convenient. Thank you. So yeah. Let me do. So I can even specify the thickness. That's actually super cool. No, let's actually do that ourselves. Let's actually do that ourselves, and then we can try the Rayleigh thing, right? So because I want it to be a little bit educational for myself, right? So let's do the resolution. Right, so the resolution is going to be like around 30, and let's iterate from 0 to 30, right? So plus I. So, and t is going to be basically, actually this has to be resolution. So I converted to float divided by resolution. So it's never going to be really 1, which is fine. So we kind of skip in 1, so whatever. So let's take that formula, right? So the first thing is 1 minus t, and we have to take a cube of that, right? So this is the cube. Which is fine. So maybe because of that, we want to have like an inverse of t, right? So which will make it a little bit easier to work with, right? So this is inverse of t multiplied by the first point, right? So this is going to be node 0. Yeah, so it's a little bit too much, but essentially what we probably want to do is vector 2 scale. Right, and we're scaling this first point with this thing, with a cube of inverse t. So then we have 3 multiplied. So let me split the screen and maybe put this entire thing somewhere here. So I have the formula in front of my eyes. Right, so I'm trying to reduce the size of the page, but it's taking too long for some reason. I don't really know why. Okay, so where is the cubic Bézier curve? All right, so this is 3 square of inverse t, and then just t. And what we're scaling in here, we are scaling the node 1. There we go. So this is the second component here. Then we have 3 multiplied by inverse t, but then square of just t, and here we're scaling the second one, right? And the last point is just the cube of t, and we are scaling the last one in here, right? So you can kind of derive that formula by basically inlining all of the lerps and stuff like that, right? So we can just like inline them. So, and in here we have plus, plus, and minus, right? So this is plus, this is plus, this is minus, and that's basically the final point. So, but you can't just add vectors together in C. So what we have to do in here, right? So let's actually put it as B. So this is the first point. Then we do vector add B. So this is the second point, like so, right, and we have to reassign the B. Then we add again this point, and then this time we subtract this point. Right, unfortunately you can't really overload the operators in C, so because of that we have to do this kind of shit. But it's, I think it's like readable to some extent. I think it's fine. Right, I think it's fine. It would be kind of nice to maybe realign some things so they look like more or less nice, so we can see what the fuck is going on. Yeah, if you align things like that, I think it's fine. Right, so this is the first thing, right? So then we add this thing sequentially and we subtract the last one. So, and this is where we kind of want to draw like a point, like a sample. So I hope I didn't make any mistake in the formula, right? So draw circle V, and we have to specify the center, we have to specify the radius. So Bezier sample radius, right, and then Bezier sample color, right, so we have to define those things. Let's go ahead and maybe define them somewhere. Right, so define Bezier sample radius. So what other radii we have? So the smallest one is 15, so I suppose, right, so this one could be just 5, right, and this one could be yellow yet again, right, so I don't really like to use too many different colors. All right, so what do we have in here? It's actually called nodes, right, so let's quickly fix all of that. So this is nodes. What else do we have in here? And that seems to be fine. And that went somewhere. Okay, so that's actually kind of funny. Why did it went completely haywire? Yeah, but that's kind of cool already. So, So maybe I fucked up something somewhere in the formula. That's definitely fuck up in the formula. I wish the website was not this slow. I'm trying to reset its size, but it's just lag. Why Wikipedia lagging? Can anybody tell me? Why Wikipedia is fucking lagging all of a sudden? Add instead of subtract, but they were subtracting, weren't they? Am I tripping? Yeah, I think I'm yeah, okay, so I saw minuses somewhere and I just thought that it's plus. Okay, so that makes sense. All right. So let's get rid of that. So I'm sorry for the fucky wacky situation. All right, so that's fine. So this is Bezier curve. So this is how easy it is to draw a Bezier curve, right? So, and that's roughly what I want you to do. Honestly, disallowing them to go over 1 was a bad idea because I want them to overshoot a little bit. Yeah, so being able to overshoot is kind of important, honestly. Right, let's get rid of that clamping. Let's get rid of the clampage. Right. So the first 2 nodes, they do need the clampage. Yeah, so because this is the function I want. Not the function I deserve, but the function I want, roughly. So, and I also want to be able to maybe adjust the zoom. Right, so if I do the zoom and I make it a little bit smaller, so maybe it should be adjustable through a wheel, but this is something that can be changed, right? So there we go. Look at that. So, yeah. So that's basically the function that I want to have in here. That's pretty cool. Right. Scroll wheel. Yeah. So it would be kind of nice to know the actual parameters of these points, right? So the actual parameters. So maybe one of the things we want to do in here, we want to draw them somewhere. Let's go ahead and draw them. We already have a font, right? So draw text XC. So raylib draw text XC. So we already have the font, and here we can use text format, and we can just, I wonder how I can actually approach all of that stuff. I need some sort of a buffer because I want to render some C code, right? Effectively, I want to render some C code. So maybe I'm going to introduce the string buffer. I know that knob has string. Yeah, it has a knob string builder. Look at that. Look at that, bro. Look at that. So let's actually introduce that. So it's going to be SB. And on every frame, what we're doing with this thing, we're actually cleaning it up. Actually, we can clean it up right before trying to use that, right? So this is going to be like this. So, and in here, what I'm thinking is that, that's pain. But maybe not. Maybe we can actually use the text format in here. Text format is actually useful for this kind of stuff. Wait. we have a limited amount of nodes, right? And we don't plan to change it. So that means I can literally just do some stupid shit like this, where I can just do it like that. And yeah, so that's actually way easier. It's actually way easier. I really don't plan to change the amount of nodes, at least for now. So nodes 0x and right, so nodes y. Let's not overthink these things. Right, so it'll be 1, 2, 3, and this one's going to be 1, 2, 3. So we got the text format. So this is the label, const char label. I wonder if I can just do something like that. Okay, that's cool. So this is the label. Position, let's say that the position is going to be just 0. I think we already have a font size. I don't want to have any spacing, and the color, the tint is going to be white for now. All right, so let's actually see. What do we have in here? All right, that's a crappy font. Holy shit. Why is this so freaking crappy? Can I reload? So first of all, let's use a little bit of Emacs magic and make the numbers a bit smaller. Maybe it's gonna be just like 2 digits after the dot. That's a bit better, honestly. That's a bit better. So yeah, so that's basically the parameters that we have. We can see them, but yeah, I think it has something to do with how we handle the font, right? So when do I even reload the assets? I don't even reload the assets at all. Yeah, unload the assets and then load the assets. And where is the function that loads the assets? Okay, so one of the things I like to do, I like to generate meep maps for the fonts. So let me do, so font equal, so generate meep maps for the fonts, and also set the filter by linear, right? So that usually improves the quality of the font generally. Yeah, that's much better. Look at that. Look at that. So that's much better. We can work with this shit. We can actually work with this shit. We can use iOzevka or Yozevka. How is it called? So let me change it. So IO assets fonts regular, right? So I think iOzevka is like works better here. I think it just works a little bit better. Yeah, so it could be a little bit smaller, honestly. Could be a little bit smaller. The text format has its own internal static buffer. Yeah. So it actually has like 4 of them or something, right? So you can basically use up to 4 text formats simultaneously, right? So it's kind of cool. So font size, let's actually reduce the font size a little bit. So I think it's going to be maybe 32. All right, so yeah, there we go. So it would be kind of maybe nice to, right, we can change this kind of stuff, right? And that changes. I want to see them in terms of actually mapped from 0 to 1, honestly. It's not that hard to do, actually. So we just have to divide all of these things by axis length. Just divide them by axis length. All right, so divide axis length. And that one as well. What the fuck is going on? Excuse me? Static redeclaration, new region following. Am I going crazy? What just happened? I think, bruh, axis length, something in the definition of axis length fucked up so freaking dramatically. Wait, what? What the fuck? Excuse me. What did I fucking do? Like, what did... Oh my god. Like I put some garbage, like, oh my god. Like I know what is going on. I know what is going on. It's probably it's a stupid C can't properly report an error or something like that. It's just like it's so freaking common. Did I accidentally? I think I accidentally removed this thing. That's probably what happened. Oh, it's so dumb. Like it happens so fucking often. It happens so fucking often. It's insane. Right. So and it's just like you forget to close one curly brace and it just explodes with bullshit. Like absolute fucking bullshit. It's like, oh, some definition on static. Fucking tell me that I forgot to close the curly brace, bruh. So fucking bad. Maybe it's hard to actually report that. To be fair, GCC developers put a lot of effort into proper reporting stuff. But anyway, so what I want to do, I want to kind of align this entire thing a little bit better. So I want you to center it. But to center this entire stuff, we actually need to know its size. So we need to do some measure text. All right, so there's a measure text XC where we do font, label, and the font size and the spacing, right? So here we can have vector2 I set label size, right? So we've got a label size. And by the way, I completely forgot that I'm also supposed to actually divide it by axis length. Okay, axis length, that one as well, axis length. Right, so let me see, yeah, there we go. So this is what I want you to see. So this is how we're going to be defining actual Bezier curves for our functions and stuff like that, right? So that's the actual definition in here, right? Honestly, I think these handles should be stuck to these handles, if you know what I mean. But that's besides the point, honestly, right? So that could be fixed a little bit later, because in Inkscape, when you move this thing around, it actually moves this thing along, right? It moves this thing along, which kind of makes sense, right? So, but for now, it's fine, it's fine. Anyways, so now we have label size. That's what I wanted. So we also need to have some sort of like a label position. Label position. So in the label position is going to be initially 0, right? It's going to be initially 0, like so. So but then we take the label position x and we add, actually add the axis length, like half of the axis length, right? So that's what we want to do. I don't know what the fuck has happened, but it doesn't automatically reload. This is because I didn't use that position that I just crafted in here. I didn't use that position. This is a label position. There we go. All right, so that put it in here. So now I can subtract half of the label size x, half of that. All right, so now it is more or less centered, but I would also like to take y and maybe subtract the whole axis length so it is on top. Right, it is on top. And it would be also nice to have some sort of a padding, like label padding. Right, so let's define label padding. Label padding. So it's gonna be maybe 100 or something. Yeah. Subtracting didn't work, so so since I'm subtracting this thing, I have to actually kind of add it in here. That makes sense. Sure. There we go. So finally I have this kind of thing. So that's the sort of value of the Bezier curve, So another thing I want to be able to do, when I press something, but I need to pick a key. So let me see. If why did you align it like that? If is key pressed, key C. Fucking okay. Right. So raylib clipboard. Set clipboard. All right. So what I can do now is maybe modify this kind of stuff. Right, and then copy paste this stuff into the clipboard, so then I can use that in the things, right? So like that's it. That's literally what I wanted to achieve, like, because I needed a function that looks like this roughly. I just defined it and I copy pasted it. So now I need to plug it into my animation. All right, I need to plug it into my animation. So let's actually try to do that. So Yesu. I'm gonna put it in here. How that function is going to look like, right? So let's actually call it Bezier. All right, so, and it's going to accept the T, right, which is understandable. And it also probably will accept the nodes, right? So it will accept the nodes, right? And let's say that the nodes is going to be 4. I know that it degrades to a pointer. No need to tell me that. Thank you very much. Right, and I suppose we can just like use the same formula that we did in here when we were rendering this entire stuff, right? So let me see. All right. So, and IT is an inverse of T. There we go. And then we can just return B. So this is literally the same formula. We might as well actually use, yeah, we can use literally the same formula in here. If we, yeah, well, why not? Right, so Bezier, we can even inline the whole shit. We are inlining the whole shit and we do nodes, and that's basically it. Right, might as well. Okay, all right. So this is literally the same formula, so to speak, right? And this is also the formula that is going to be used in animation, right? All right, that's pretty cool. So let's actually try to, oh, okay, so I forgot a very important thing in here. P, just remove the whole thing, right? So because it's parameterized by the nodes now. So we have in here, so return, yeah, this one is a little bit painful because that's not how it works. That's not how it works, but we can actually return vector2. Okay, so let's actually make it return vector2. But in our case, if we're going to be using it as a time function, we have to only take y, right? And this is why we must keep these things at 0, 0, right? So that's why we have to keep them at 0, 0, otherwise it's not going to work, right? So this thing has to be 0. So what's funny is that x of this parameter is not needed, and x of this parameter also not needed. We only care about their y's because their x's are snapped to 0 and 1 anyway. Though not necessarily, honestly. What if we want to define shit like that? Right, so what if something like that is also... Yeah, I can see that. So the only situations that we want to kind of forbid is this one, right, when a single right thing is sort of like goes... Maybe it's also fine. Honestly, why am I putting all of these restrictions, right? So if this is the function that I want to have, like, let me just have that function. Like, who the fuck are you to tell me? So, yeah, I didn't see any problems with that, right? So just allow this stuff. Just allow this stuff. By the way, I wonder if I can now do an opposite operation where I can control V into, like, an array into this thing, and it will reset the nodes like that. That sounds like a very interesting idea, honestly. But if like I have to, can I scanf this mother flipper? Can I just scanf it? Wait a second. If is key pressed key V, so it's get, right? So get clipboard. Oh my god. Okay. So get clipboard. So scanf. S. Why everything's so slow? So string. Can I literally do that? Man. So in scanf, they are supposed to be pointers, right? So I haven't used scanf for quite some time, actually. Right. So how do you use scanf? Do you pass the pointers to scanf, right? If you want to modify the things. Chat, I need your help. For one time, do you do shit like that? Yeah, it's pointers. Thank you so much. All right, so now that means I have to go through all of these things. And just, oh, fuck, shit, damn, bro. Okay, so it's fine. Chat, everyone calm down. Everyone calm down. Everyone calm down. All right, so multiply axis length. Right, so can I just, okay, so I probably can do something like that. Right, so this is basically what I want. All right, so let's reload this entire stuff now. It's probably gonna crash. I'm pretty sure it's going to crash, but I'm gonna copy paste this stuff like that. And oh fuck. Oh my god. Ah, X kill, fast. All right, so it's not even dead. Jesus, bruv. Okay, kill this shit. Okay, so it's dead. All right, it's fine. Okay. So now let's not do that. Fuck that. It's kind of a cool idea, but I just don't want to spend time like figuring out how to do all that. It doesn't matter. All right. So now what I want to do, I want to somehow tell my animation framework, bruh, use Bezier curve. Use Bezier curve. How can I do that? How can I fucking do that? I want to be able to do that on a scalar, right? So first of all, let me grab this shit and move it into the function with interpolator. So I have a special module with interpolators and shit, and this is what I wanted like to have it, right? So this is gonna be static inline, right? So it's gonna be shared between different things and stuff like that, right? So this is what it is. By the way, this is not just Bezier, it's a cubic Bezier, right? So it's a cubic one, and it's indicated by the fact that we accept 4 of these things, right? So it's a cubic Bezier. So the only problem that I have in here is that we don't import array math, right? So let's actually try to import array math and see how bad it's all going to be. So it's a cubic. It doesn't have it because we have to actually import interpolators. I think it's S. There's multiple of them. Okay, there we go. That's cool. Scanf by default reads from std in. Didn't I use? I thought I did scanf. I thought I did scanf. Did I forget extra s? I think I forgot extra s. I already removed the code. I'm sorry. I'll try to do that next time. Right. So sorry about that. Sorry. Yeah. Okay. God damn it. All right. So I'm an idiot. Isu. I'm gonna sneeze, by the way, chat. Get ready. Debated. How we're going to be approaching all of that? So I want to go into the tm.c and what we want to have. Actually, I probably want to copy paste move vec2 data. Right. So I'm gonna literally copy paste that. Where is the place where you find custom? Yeah, here they are. So here they are. Move back to Bezier. Right. So, and what we're going to be doing here, instead of using interpfunc, we're going to be using actually a bunch of nodes, 4 nodes, like this. So yeah, I don't really know how to incorporate that into the system of interpolation function that I already have, right? Because of that, I'm going to have a separate sort of like a data thing. Okay, that's very cool. Now I need to have something like move vector to Bezier, Emacs, shut the fuck up Emacs, Bezier update. So in here we're going to be accepting the data and also the environment. So let me maybe copy paste the implementation. So it's going to be task C, move back to update. Where is the implementation? Okay, so there is an internal wait task, right? So this thing kind of inherits the wait task. So because of that, it just has an internal thing in here. So if it's already done, we also declare that task done. So this is basically a call to a superclass, right? It's a call to a superclass. So if the task has not started, right, we initializing everything in here, we initializing. Then we are updating the internal task. We are updating the internal task. Right, and then if the target, like the thing that we want to modify, is set, we're lerping from the start to the target using this interpolation function. But here is the catch, right? Here is the catch. Now we have to use a cubic Bezier interpolator. We provide the interpolator here, and as a Bezier definition, we are using data nodes. Maybe I should call it Bezier, right? So I think it would be better to call it Bezier instead, right? So that's how we're going to be doing all that. That's literally how we're going to be doing that. But here is the thing. This motherfucker returns you a vector. So what we have to do, we have to use y, right? So I think that makes sense in that particular regard. We just use y. And that thing would interpolate everything properly. And then we just return finish. So there you go. So here is the implementation of this class that uses Bézier curve for interpolations, right? So that's what it does. So we defined the data of the class, right? And we defined the update method. Now we have to do the constructor, right? So let's actually do the constructor. We need to construct this entire thing. All right, so we need to create a function that returns this data. Let's actually call it just the name of the class, right? So, and in here, I suppose it has to accept all of the stuff that the move, yeah, so it have to accept the value that we're modifying. It has to, may I actually move my camera a little bit down so you can see shit. So we have to accept the value, the target, the duration, and here we accept interpolation function, but we're going to be accepting Bezier, right? So let me grab that. So we're going to have that, and then we're going to say vector to Bezier. So there's going to be 4 of them. And what we're going to be doing in here, we're going to just return this kind of thing like so. So what do we have to initialize in here? So yeah, so this is basically the things we're doing. We are calling to a constructor of the superclass, providing the duration, then we set the value and the target, and here we have to provide, and this is very interesting point. So I didn't think it's not gonna work like that, right? So we literally have to do memcopy. Right, I think that's what we'll have to do. So let me quickly do something like this. Right, so it's going to be data. We're not going to do that, but what we're going to do is we're going to take the data, we're going to use Bezier. So this is the destination, the source is this one, and then we're going to say the size is the size of this whole thing. Right, and then we return the data. Jeffrey Bezier, former CEO of Amazon. That's very funny. All right, so we created the constructor of the data, but the data of the class is not useful. We need to wrap it into a task that is allocated in the arena somewhere there. That's what we have to do. So what I'm going to do, I'm going to create move vector to, it's actually task move vector to Bezier. All right, so it's going to accept all of these things in here as usual, but it's going to return a task instead. And on top of that, it's also going to accept arena, where it's going to allocate all of that. Right, so what we're going to do is we're going to just construct this data as usual. Right, so there's going to be data, and we just do stuff like that. Value, target, duration, Bezier. Right, and we need to return a task. So the first thing we have to provide in the task is the tag. We don't have a tag for that stuff yet, right? So task move vector to Bezier tag, we'll have to register that thing. And then the data, right? So what we're gonna do, we're gonna actually take that data that we constructed in here, and we're gonna actually move it into arena. So memdup data, actually arena, pointer to the data, and then the size of the data. So that will allocate enough memory in the arena. We're going to move the entire data into there, and then we just return this entire task. So we now have a task and stuff like that. If we try to build this entire shit, memcopy is not found, this is not a pointer. I see. Oh yeah, but why is this not a pointer? What the fuck is this shit? It's supposed to be a pointer, bruv. Ah, I see. I did a fucky wacky, meine Freunde. Okay. So what else do we have in here? Memcopy. Expected. Okay, so semicolon, that's fine. What else do we have in here? We don't have this tag. So we need to actually allocate this tag in here. And let's actually find the tag. So this is where we are registering all of these motherflippers, like so. Task vtable register, right? And this is going to be task funcs. And what we're doing here is just update move scalar. What was the move vector to Bezier update, right? So that's basically what we're doing here, right? So this is that one, and we just do it like that. So that's basically it. Cool. Finally, we created a class. So we created a class. What we need to do now, we need to use that thing somewhere, right? We need to use that thing somewhere. I want to use it when we highlight the, the symbols, right? So let's actually go back into the Turing machine animation, right? So this is going to build libtm, like so. Actually have to do it like that probably. Boom. All right, so let's take a look at all of that stuff. So as you can see, there, like, these things sort of bump up, right? You can see them, right? So you can see them bumping up. So I want them to overshoot a little bit and then go back. So that's what I want to do. So their interpolators that is responsible for their size, right, is called, I think, bump. Yeah, there we go. So we have a rule which is an array of symbols, and they have corresponding bumps. Where do we use bumps in here? So here they are. So for the bumps, what we're doing, we are essentially, so we're just interpolating them like that, so which is understandable. So we actually use them in so many different places. So what I'm thinking is that maybe it would be nice to factor them out somehow, but maybe not. What we can do a little bit of this kind of stuff. Move. Oh shit, I just realized that I'm a fucky wacky idiot. Damn. So this should not be vector 2, this is supposed to be scalar. Alright, that's very easy to fix, honestly, right? So it's gonna be just a mechanical substitution of like vector 2 and scalar. Alright, it's fine, everything's fine, chat, calm down, everyone calm down. So this is just vector 2 scalar, right? So this is gonna be just like that, and we just mechanically substitute this shit, okay? Okay, don't tell anybody. Don't freaking tell anybody that I did such a fucky wacky. Don't fucking tell anybody, okay? So it's not a vector, it's actually scalar. Right, so I also want to query replace vector 2 to float, essentially. Yeah, this one is weird. I'm gonna skip it for now. So this is just floats. Fuck, not the Bezier. All right, so the Bezier has to stay vector 2, actually. Believe it or not, it has to stay vector 2. Right, and this one has to be just a lerp. All right, so let's actually see. And if we rebuild this entire stuff, is it going to... Okay, so there's some stuff in here. Cubic Bezier is not compatible, but yeah, so this has to be vector 2. That's understandable. What else do we have in here? Okay, so let me find the tags. So this one has to be scalar. All right, and there's the last one that is not compatible, scalar. And this one is also scalar. All right, looks good. Look Gucci, looks fucking Tamagotchi. Okay, cool. So let's find the bumps. Let's find the bumps. So what I want to do is move scalar Bezier. All right, and we want to, in terms of Bezier, we want to define it some way here. So this is going to be vector Bezier 4, and let me find the definition of that curve that we created, right? So we created a tool, and here is the curve, right? And that's the curve we want to use, honestly, right? So that's the curve we want to use. We're going to just put Bezier in here. So let's see if this entire thing is going to compile. It doesn't fucking compile because why? So yeah, so we have to get rid of the function pulse. All right. I wonder if we can use a little bit of a Emacs magic, if you know what I'm talking about, to sort of update all of these things in here. So every time we sort of, yeah, so these things are basically the same. Right, so that means I can just go like that and use Bezier, then go on the other side, then go a little bit in here, and then replace everything with Bezier. So now, for all of the bumps, if we take a look at them, right, so bump, if we iterate through all of them, they're using the Bézier curve shit. Yep, so that's pretty cool. Hopefully that will actually work. All right, I'm gonna refresh and let's see. Update. Okay, so let's slow down. All right, so something... What the fuck? What the fuck is going on? I love it. Epic. Absolutely fucking epic. All right. We implemented Bezier curves. Thanks everyone for watching. So yeah, that's kind of interesting. That's kind of interesting. Wait the fuck, what the fuck is this? Why is this -1? Freaking... Right, so the why shit. This fucking why shit. Yeah, coordinate system. Coordinate system fucked me in the ass yet again. Why they keep fucking me in the ass yet again? Bruh. Okay, let's try to construct a different curve yet again. Okay, so we have Bezier, right? So let's go. So we kind of want this kind of thing and another thing that overshoots. That's what we want, roughly. Not that much, but I mean, kind of. Yeah, a little bit overshoots. So, and obviously this shit is not correct, right? So this is the second one, and it has like a minus. So maybe what we have to do is just get rid of the negative, I suppose. Yeah, so just like invert the negative. So I think it's easy to fix relatively. Just invert the negative, and that's gonna be it, I think. Yeah, maybe that will fix it. We'll see. So Bezier. Where is task? Yeah, so here it is. We don't even have to do it like that. Right, let's get rid of the minus. Let's get rid of the minus. Because, yeah. So yeah, so it's basically their equivalent in that sense. They're equivalent. Okay, so let's rebuild everything and let's take a look at the Turing machine. Right, what do we have? Funnily enough, there's something like, why does it doesn't really go all the way through? Like, what's up with that? I don't get it. Like, why doesn't it go all the way through? It's kind of did the thing, okay. So, but it doesn't go all the way through. So I kind of expected it to actually do that, but it didn't do that. So let's see. All right, it keeps growing, and it even went a little bit down. Right, it even went a little bit down, but then it didn't fully finish. So there's something wrong about, maybe we have to detect that we're finished and we have to set it to 1 or something. Yeah, so let's find where we do the update. Yeah, I suppose when we are finished, right, so we updated this entire stuff, we take the t, and is that t even... Well, let's do the following thing. That, and if finished, can we just like simply set this entire stuff to literally like 1, right? So if we reach the finished state, just hard code it to 1. It's kind of a hack, but I mean, maybe it will help. Maybe it will help it. We'll see. All right. So we're looping from that to that, and we're using 1, right? So that should work, I think, right? So that I think should work. Okay. No, it doesn't do shit. Why? That is bizarre, honestly. Because the same sort of like a function, it's supposed to do that. All right, so let's explore that function then, Bezier, and what's wrong with it? What's wrong with that specific function? We may want to do some sort of like a Bezier test, C. Bézier curve, yeah, exactly. So let's include maybe array math, and stuff like that. And so this is this, and let's just return Brazil curve. Very funny. Okay, so yeah, what I want to do is essentially just go from 0 to 30, right? So maybe we can actually say that this is a resolution 30. I just want to see how it looks like, right? I just want to see how it looks like. So then I have like a float t, float I divided by res, and then we can, so we want to also interpolators, and that includes array math as well. We can do f, right, and yeah, so this is t, cubic Bezier. We provide the t and the Bezier. All right, so that's cool. So we also want to put the new line in here. So fuck, we probably have to do some shits with the path, because I can't just build Bezier test C, because it doesn't see interpolators, right? So we can do src, right? So and array math, we can do array lib. Emacs, please autocomplete stuff for me, include. All right, let's go. So what do you want from me? Assert. Okay, so include assert. Well, I mean, we probably want to include asserts in the interpolators themselves. Okay, and then here we want to do stdio. So please, okay, So that means we have to link. Oh my. Okay. So can I add that to knob or something? Is there any easy way for me to add it with knob? I can probably build an exe. Right. So yeah, I think I can build an exe very easily. So let's quickly do that. So build Bezier test and src. Well, actually not an src, but somewhere here. Bezier test C. That should be enough, I think. All right. Apparently, I have all of the necessary machinery to build all of that stuff. Interpolator C. So it doesn't include build exe. We may want to actually include. I see what's going on. So maybe what we want to do in here is just include src into the include path. I think that might work for us. Okay, so that's cool. And in here, what we're using y. All right, so that's also very cool. All right, so let me now try to run all of that stuff. So Bezier test. Okay. So that's I think I know what the fuck is going on here. Because bump, freaking bump, it's a problem with my setup. Bump is an additional size. So because of that, it has to go back to 0. So that's what I'm just being an idiot. Everything works as intended. But yeah, so this is how the Bézier curve goes, right? So it goes back to 1, so everything's fine. Everything's fine, chat. Everything's fine. So let's go back to the Bézier curve application. Right. So let me try to maybe run it. So lib Bézier. All right. So I think I want to clamp the first and the last node. SOC Bezier. Let's find the first and the last node. So if we're dragging around, after dragging, like always after dragging, what I want to do, I want to take the last node, so the first node, nodes, I need an easy way to just set, yeah, maybe it doesn't matter, whatever. So this is what I roughly want. And then, yeah, I need to actually zoom out a little bit. Where is the zoom? Can I put half of this thing? Yeah, there we go. That's what I want. Isn't that cool how I can just zoom out like that? I think it's pretty cool. Right. And like I don't have a zoom out functionality in my application, but I can just like hot reload the thing. Yeah. All right, so if I take this thing, I need to get rid of all of the minuses. Right, so this is the minus, this is another minus. And this one probably has to be just 0, right? So in terms of like y, it is 0. In terms of x, I would actually set it to 1, right? So I can always adjust this kind of things manually. And this is our new curve, right? This is our new curve. Yeah. But to be fair, yeah, I actually wanted to use curve not on the bumps, but on the cell switches. Okay, so that's I already tired, right. So I'm already streaming for almost 3 hours and I'm starting to confuse things, so please forgive me. So we still need the previous one. We still need to use the previous one, but we need to apply it on the cell switches, right? So that's what we have to do in here. We have to apply it on the cell switches, so that explains it actually. All right, so let's take a look at the TM. So let's maybe get rid of the Bézier curves in all of these places, right? So we don't really need them in here, honestly. So I can probably select all of that stuff. Yeah, there we go. So there's a watermark, that's fine. So I want to use this Bezier curve in right head. That's where I want to use it. Okay, so let's find the definition of right head. Right head. Where is the constructor? Okay, so when we're writing the head, we're using weight data. Okay, that's very interesting actually. We are using okay, so we're actually doing all of this stuff directly. So that means I can kind of do a little bit of a trick in here. So I can do Bezier and just do it like that. All right, so that actually makes it super easy to just start using it in right head. Okay, so cubic Bezier. And what else do we have in here? So what you don't like, motherflipper? It's because it's a vector. Okay, so let's take y. All right. So let's close this thing. Man, this is kind of makes Panim some sort of a platform, because the animations could be like separate applications that are useful for different cases. What if we allow Panim run several animations at once and basically switch between them? Right. So that would be kind of cool. So I'm working on one animation. I loaded up the Bezier curve editor. I switched to it, quickly updated my Bezier curve, switched back to my animation, and maybe I can have like several of them, maybe even like a list. So the whole thing becomes sort of like a supervisor for these applications and stuff like that. That is so cool. Can you make Panim a code editor? That will be also kind of interesting, right? So, yo, this turns into like a platform and shit. What the fuck? So the system that loads ELF files, Panim is now, yeah, it's an operating system. Right, I turned my animation framework into operating. You guys asked me to develop an operating system. There you go, here's the operating system. There you go, operating system. Isn't it cool? I think that's pretty fucking cool. Anyways, so I wonder how exactly is it going to go. Yesu, kawaii freaking desu. I am afraid that if I overshoot the switching of the cell. Okay, so cell. I have a notion of the cell. Listen, chat. This is actually very important. So this shit may fuck up. Cell. You saw how when the cell switches, it switches from one symbol to another. This is the structure that does that. You have symbol A and symbol B, and T basically interpolates from one symbol to another one, symbol A, symbol B. Right. So if T is equal to 0, symbol A is displayed. If T equal to 1, symbol B is displayed. And it does this pretty cool interpolation between them. I have a feeling that if T becomes greater than 1, symbol A may start actually inverting itself. So it's going to look like shit. So let's see. I'm just warning you that it might look like shit. Right? Just warning, just a friendly reminder that this shit may look like shit. Okay, so let's see. All right, so let's slow down. That looked fine. Notice how it does overshooting and then brings back. Look, so I'm gonna slow down the time. Look, it grows bigger and then goes back. All right, so it's reduces. Okay, so it switches the state and shit like that, right? Whatever, right? It goes into that, then it overshoots a little bit and then goes back. We achieved that through custom Bezier curve. We achieved that through a custom Bezier curve, right? So I don't know if it actually made the animation look a little bit better. So let's actually see it at full speed. It looks a little bit better, but now I have more control. Well, no, I didn't use Bezier curve for switching the state, I think. Right, so let me see how I'm switching the state. So the plug reset, not really plug reset, but let me see. So yeah, this is, and I'm just writing, yeah, so there is a task write cell, so there's a more generic task to do this kind of shit. Okay. So write cell, yeah, okay. Let's copy paste a little bit more. More copy pasting, chat. More copy pasting. Where is that? So right head update. Here it is. Got you, mother flipper, got you. Got you, hyper. Alright, so this is what we can do now. So I think hopefully it will actually start doing some cool shit. So what the fuck is this? Okay. It's actually data cell, I suppose. Yeah. It's a data cell, but data cell is confirmed. We don't even check whether data cell is available or not. Maybe we should, but whatever. Okay, so that's fine. Data cell. All right, let's go. So it's needed for this state, right? So we used the overshooting for the cell, but we also need to use it in here as well. Okay, so this is the most interesting part. So let's actually see that in slow motion. They kind of synchronized. A little bit of a tweaking required for them to be... You didn't see shit, by the way, I just realized. Yeah. So I'm trying to synchronize these two holes, right? So let me try to do that one more time. Okay. Yeah, so I was trying to synchronize two holds to sort of land down at the same time. That's what I was trying to do. And I think I'm kind of there. Maybe I should use a custom curve for the hold as well. Yeah, it's kind of close. It looks better, but a little bit of a tweaking still required. A little bit of a tweaking. So it's probably very obvious that they're kind of out of sync in a slow motion. Let's do the slow motion. So this is that. And let's go. Yeah, you could see that there was a little bit out of sync, but maybe it's when it's fast, it's kind of fine, probably. Yeah. So, but at least now I have a mechanism that allows me to edit those Bézier curves. Right, so, and I have more control over how I play all of these animations and stuff like that. So I probably need to bring the zoomage a little bit closer, right? So where is the zoom? So let's actually make something like 8. Right, so it's a little bit closer. So this is what we developed on today's stream, right? So we have a custom Bezier curve editor and stuff like that that we can use in animations. I'm going to polish it up, right? So there's some things that I would like to add to this entire stuff, all right? But overall, I think it works fine. I think it works fine for now. So thank you so much, Julian9601. Thank you. All right. So today was a pretty cool stream, I think. Thanks everyone who's watching right now. I really appreciate that. Have a good one, and I see you all on the next recreation programming session with Mr. Zozin. I love you all. Mwah.